If you've ever watched a crime show, you've probably seen the scene. The tech guru furiously types away and bam, a criminal's deleted files are right there on the screen. But what's the reality? Well, it's a little less Hollywood and a lot more science. Today, we're going to pull back the curtain on computer forensics and see how investigators really uncover digital secrets.
Okay, let's get right into it. The whole forensic process really boils down to this one question. It's not about flashy hacking or guessing passwords. No, it's a really careful, methodical process that starts the second a device is taken into evidence. And the absolute #1 rule, the golden rule, is this. You have to protect the original evidence. See, just turning on a computer can change thousands of files. We're talking logs, temporary files, all sorts of stuff. It's literally like walking through a crime scene and leaving your footprints all over the place. So that original device, it gets locked down. Investigators never work on it directly.
So, if you can't even touch the original, what do? Well, that brings us to the first critical phase of any investigation, acquisition. This is all about making a perfect, verifiable, bit-for-bit copy of the original hard drive. You create a clone that investigators can safely poke and prod without ever risking the real thing.
To make that copy safely, investigators use this really important piece of hardware called a write blocker. The best way to think about it is like putting the original drive inside a sealed, transparent evidence box. You can look at everything, you can copy everything you see, but you absolutely cannot change a single thing. It guarantees that original evidence stays completely untouched.
Now, it is so important to understand this. A forensic copy is not just dragging and dropping files into a new folder. A simple file copy only grabs the stuff you can see, right? It totally ignores deleted files and this other thing called slack space. Those little leftover bits of storage where fragments of old data can hide. A forensic image, on the other hand, is a perfect digital photocopy of the entire drive. It captures everything, including all that hidden and deleted data.
But how you prove the copy is perfect? That's where a cool process called hashing comes in. A special algorithm creates a unique digital fingerprint. It's just a long string of letters and numbers for both the original drive and the new copy. And get this, if even one single bit is different between the two, that fingerprint will be completely different. It's the mathematical proof that the evidence is legit and hasn't been tampered with.
So now we've got a perfect, verified copy of all the data. Problem solved, right? Well, not exactly. Now we have a brand new problem. There is just an overwhelming amount of it. We're talking millions, sometimes billions of files, and most of them are totally irrelevant. The real work is just getting started.
And this chart just puts the scale of that challenge into perspective. I mean, look at this. On a typical computer, 90% or even more of the data is just the operating system and standard program files. The stuff that might actually be evidence, the documents, emails, photos, it's all buried in that tiny little slice.
So how on earth do they manage this? Well, you're not going to see an investigator scrolling through every single file by hand. No way. They use smart, automated techniques to filter out all that noise. They use hash analysis to automatically ignore known safe system files from Windows or other programs. And they use header analysis to spot files that someone tried to disguise, like a malicious program renamed to look like a harmless picture.
Okay, now we get to the part that feels like it's straight out of a movie. Extraction. This is where investigators dig deep into what's left to find hidden clues, pull apart compressed files, and basically bring to light all the information that suspects tried to get rid of. A key technique here is something called file carving. See, when you delete a file, the data isn't actually erased right away. The computer just marks that space as available. File carving tools scan all of this so-called empty space, looking for the specific starting and ending signatures of known file types, like JPEGs or PDFs. Then they reassemble them. It's how they can recover photos and documents that a user thought were long gone. But carving is just one piece of the puzzle. The extraction phase is all about piecing together the story. Investigators will run massive keyword searches across the entire drive image. They'll decompress zip files to see what's hidden inside, and yes, sometimes they even try to crack encrypted data. As they find things that look important, they bookmark and tag them, slowly building a timeline of what actually happened.
All these concepts can sound a little abstract, so let's walk through a quick case study to see them in action. We'll focus on something super common in digital forensics, tracing a malicious email.
So here's the problem. An employee gets a threatening email, but the from address is obviously fake. It's been spoofed. All the visible information is a lie. So how does an investigator find out where that message really came from?
Well, the answer isn't in the part of the email you actually read.
The secret is hidden away in what's called the email's full header. You can think of it like a hidden travel log that every single email carries with it, containing all this metadata that traces the path it took across the internet to get to you.
The process here is really systematic. After making a safe copy of the email, the investigator pops open that full header, the part your email client usually hides because it looks like a bunch of code. By reading the received lines from the bottom to the top, they can trace the email's journey backward. That very first IP address in the chain, that's the digital starting point. From there, they can use online tools to trace that IP back to an internet provider and a location.
All right, so we've seen the process. Now let's take a quick peek inside the investigator's digital toolkit and look at the kind of powerful software that makes all of this happen. These are like the digital scalpels and microscopes of their world.
A real cornerstone of the field, especially in the open source world, is the sleuth kit, which is usually paired with its graphical interface, a tool called Autopsy. It's an incredibly powerful and accessible suite of tools for doing a deep dive analysis of file systems.
This thing is a total workhorse. It lets investigators do basically everything we've been talking about, digging through the file system of that forensic image, filtering out known files with hash sets, running powerful keyword searches, and, maybe most importantly, building a timeline of events to see what a user was doing and when.
But sometimes, the most important evidence isn't even on the hard drive. It's in the computer's live memory, or RAM. For that, investigators have to turn to a totally different kind of tool, like the volatility framework. What volatility does is analyze a snapshot of a computer's RAM, and this is absolutely critical for investigating malware or a live security breach because it reveals what was happening right at that moment, what programs were running, what network connections were open, all of which disappears forever the moment you shut the computer down.
And that really brings us to a final thought. The work of a digital forensic investigator really shows that our data has a life of its own. Things we think are deleted can often be brought back, and pretty much every action we take leaves some kind of trace. Makes you wonder, right? In a world where everything is recorded, what digital footprints are you leaving behind?